In the second part of section 6.1, we'll be solving linear equations. So before we were given some value to test if it was a solution. Here we're going to go ahead and find that value ourselves. So we will be reviewing keywords and phrases such as equation, solution to equation, which are familiar, solving the equation, which is the process we go through to find the solution. We'll check the solution. We're going to talk about what it means to be a linear equation, as we'll graph linear equations later in this chapter. We'll isolate the variable, consider properties of equality, ideas of balance in the equation. We've already mentioned lowest common denominator. And we're going to look at some words such as contradiction, identity, and the related terminology. So, two algebraic expressions joined by an equal to sign form an equation. The solution to an equation is the number that replaces the variable to make an equation, or to make the equation a true statement. So the value we could plug in, and at both sides simplified to the same quantity or the same expression. For example, we can use mental math to find the solution to the following equations. So if you just look at this as x plus 5 is equal to 10, you think about what is x? Well, if I replaced x with 5, we would end up with 5 plus 5 is equal to 10. So it's pretty easy to just say, oh, okay, the solution here is x equal to 10. And, well, let's maybe start using these basic examples as a systematic. How would we approach this systematically? Well, we'd want to maintain balance. So if we look at this equal to sign, I could bring this quantity over to the right as long as I do the same thing to both sides of the equation. So I could subtract 5 here, and if I choose a side to subtract 5 from, I must do that to the other side. So the 5 plus minus 5 cancels, it just is 0. So that's why we have so this is like plus 0, but that doesn't need to be written. And then, of course, 10 minus 5 is 5. All right, the second one, again, we just have subtraction right here. So you could think about this mentally and just say, hey, if x is 15, you could take away 5 and you get 10. So here, the solution is x is equal to 15. Again, how would you go ahead and solve this systematically? Well, you would say, okay, I want to go ahead and get rid of this 5. I want to isolate the x, and I don't think I dropped that word before, but I'll drop it now. If I add 5 to the left side of the equation, I must add 5 to the right side of the equation. So again, the 5s are opposite signs, so those are 0. So the x came down here, and 5 plus 10 is 15. On the next one, well, they're written next to each other. This is multiplication. And again, we saw this when we replace a value, you just multiply them. So you could easily see if you were to replace x with a 2, 5 times 2 is going to be 10. So we know that the solution here is going to be x is equal to 2. To systematically do that, I'm going to choose to divide this by 5, and then I must also divide that by 5. Again, a 5 divided by 5 right here is going to be 1. So this is technically 1x, but 1 times anything is the anything. So we can just go ahead and just leave that as x if we would like. Let's do that. And the last one. This time we have the x in the numerator. So again, mentally thinking through this, well, if we want this to be 10, what we'll need to go ahead and do is start with a 50 up here, because 50 divided by 5 is going to be 10. Well, how do we systematically do that? So let's just write down our solution first, namely that x is equal to, what do we say, 50? Yeah. Well, I need this 5 in the denominator to be canceled out. So I'm going to multiply this by 5. And that means I'll multiply this by 5. So again, this is technically I'm multiplying by a 5 over 1, but what will end up happening is you'll end up with that 5 over 5. So then you'll just be left with 1x or just 1. So there is the solution. Those Pretty easy to do mentally, but those provide the techniques and the systematic approaches we'll need to go ahead and tackle more complex or complicated equations. So to go ahead and prove the solutions using algebra, we'll use properties of equality to isolate the variable. And again, I already talked about that above, so we're just formalizing it here. In other words, we'll get the variable by itself on one side by adding, subtracting, multiplying, or dividing the same number on both sides, as illustrated above. And again, we went ahead and just simply looked at the subtraction property, the addition property, the division property, and the multiplication property above. So that's what this space could go ahead and further illustrate. But now that we have those basics out of the way, let's go ahead and use more than one of those properties to solve the equations. So in the case of number 1, we have 2x minus 9 is equal to 19. Well, it's a little harder to figure out what to plug in for x to get a true statement. So what I'm going to do is essentially I'm going to work our order of operations backwards to get things away from the x. So again, I'm going to do them backwards. So I need to deal with the addition and subtraction first. So I want the x by itself. So I'm going to look at the 9, which is being subtracted from the 2x. And I'll go ahead and add 9 here. And to maintain equality, I'll add 9 there. So the next line, I'll have 2x still. Those will cancel or just be 0, but I don't have to write that. And then we're going to end up with 19 plus 9, which is going to give us 28. So that's done. Now I'll go ahead and deal with multiplication and division. I do have multiplication here, so I'm going to divide by 2. And then I'll divide by 2, both sides of the equation. And then we're left with an x here and a 14 here. So our solution here is just 14. And if you want to check that, you could go ahead and just replace it in the x in the original. So to check our solution, we would just do 2 times 14 minus 9. And we'll check if that is equal to 19. And this is 28 minus 9. Is that equal to 19? Yes, because you take away 9, you end up with 19 equal to 19. So yes, x equal to 14 is our solution. There's no exponents or parentheses here. That's fine. Let's go ahead and look at the next one. Number 2 is very similar in nature, but of course we have a negative 3 in front of the x. So let's go ahead and get to that part just to see how it works out. So I'll subtract 4 from both sides. And then we end up with a minus 3x. And then we end up with a 21 on the right-hand side. And then I have to divide by minus 3. So remember, the negative, I want to divide by the negative, so all I'm left with here is a positive x. And then 21 divided by 3 is 7. But the fact that we have one of those values as negative means our solution is to be minus 7. You could check that if you would like. The next section, it tells us there are times when you need to simplify before using the distributive property and or combine like terms on one side. So in the case of number 3, the variable we're solving for is t. But before I start moving things around, like I could subtract 5 now if I want, but I would always encourage you to simplify first. So the 4 will come down. I'll leave the 5 here, but I want to distribute the 2. So this is going to give me a plus 2t plus 2. And then before I do any sort of movement, we have 4, and I'm going to go ahead and combine the like terms of the 5 and the 2. So this is 7 plus 2t. Okay. Now that we have everything simplified, I'll go ahead and do the properties above. So I'll subtract 7, just going backwards in my order of operations, So that gives me minus 3 is equal to 2 times t. And then I'll go ahead and divide both sides by 2. I'm going to go ahead and put the answer over here on the left. So we end up with t is equal to minus 3 over 2. And again, we can go ahead and leave that as a improper fraction. And notice that technically we would have had like t is equal to minus 3 over 2 if we kind of kept the same pattern or the same, we didn't mirror it. But again, equations are true or can be read either way. So we are fine just turning it around. All right. Number 4 is very similar to the one we just did, except for solving for x. I would encourage you to pause and try it first. Here's the solution. Simplify first. Let's distribute the 3. We get 6x minus 15 is equal to 15. I'll add 15 to both sides. That leaves me with 6x is equal to 30. And I will lastly divide both sides by 6. My solution here is x is equal to 5. All right, so those are the basic ideas so far. Let's see what we'll encounter on the next set of exercises. There are times when the variables are on both sides, and you'll need to collect them on one side and move all of the constants to the other. Okay, let's zoom in and see what that means. So notice that both sides are already simplified. There's no lower-like terms, so do that first. Now, what you want to do is pick a side for the x's and pick a side for the constants, the values that don't have a variable next to it. You can really choose whatever you want, but what I tend to do is move the x's to the side that has the larger variable coefficient. So I'm going to go ahead and subtract 6x from here, but that means I have to also subtract 6x from here. So again, at the same time, you could go ahead and move the constants, but for the first time we're encountering that in these lessons, I'm just going to go ahead and do that in 2 steps. So 8 comes down, 10 minus 6 is 4x, and then we add 12. So now I'm going to go ahead and, this is very similar to the ones before. I'll take away 12 from both sides, and I end up with minus 4 is equal to 4x. And then I will divide both sides by 4. Negative 4 divided by 4 is a negative 1. And then we have x. And again, it doesn't matter that the x is on the right side of the equation. Our solution is negative 1. Okay. Number 6 is very similar to the one we just encountered. I would encourage you to pause and try. Here's the solution. I'm going to again choose to move the 2b over to this side and the negative 4 over to this. And I'll do this in one step this time. So I'm going to subtract the negative 2b. Remember, whatever I do to one side, I must also do to the other side. So then I'll also, at the same time, because I'm moving the variables to this side, I'm going to go ahead and add the 4 to both sides. And that leaves me with 2b. And that is equal to 10. So not 2b, but 2b, not 2b. Okay, bad joke. And then we will divide both sides by 2. And we'll find b is equal to 5. All right. And then 7. There are times when all of the previous strategies need to be used. Again, my suggestion is to simplify both sides completely before trying to move anything. It might even just be let's focus on one side at a time. So 7, I'm going to distribute the 4. So that gives me 4x plus 8 minus 6. I'm not even going to touch the right side yet. I just want to get the left side simplified. So our like term, of course, is 8 and the minus 6. So this is going to be 4x minus plus 2. And now I'll go ahead and do the other side. So I'll distribute. So this is equal to 6x minus 8. And nothing more to simplify there. I'll just rewrite that down to bring everything in line. All right. So Now we're very similar to what we just encountered in 5 and 6. I am going to choose to move the 4x over here. Again, I like to always move the smaller of the x's with it. That's just personal preference. All right, so I'll have a minus 4x, both sides of the equation. Again, kind of just thinking, okay, there's the two sides, do the same thing. All right, and then I have to add the 8 to both sides. So that gives me a 10 over on the left, and then a 2x on the right. And again, divide by 2, and we find 5 is equal to x. So same value as before, just an example illustrating all of those strategies. So those are the various strategies, and again, you could always extend this with exponents and various other operations and inverses, and we really could dive deep into that, but those are the basics. And there's a couple scenarios that we're going to run into as we solve. We want to make sure we can classify them appropriately. So all of the scenarios that we did above fall into this first row of this table, where is some specific solution at the last step, x equal to 0, x equal to 5, what we encountered up here. There's no point calling this a true or false statement. We're just finding the solution, and there's namely 1, and our answer is just x equal to whatever we found. But these two cases down below, well, there's the case where there's infinitely many solutions, or you can always say your answer is all real numbers. This is sometimes referred to as an identity, or where you simplify everything and you get something that's not true, a false statement. In this case, there are no solutions, and you can just simply state that. This is sometimes referred to as an inconsistent equation. So let's go ahead and see what happens in each of these down here below. On number 8, I'll distribute the 3, so we end up with a 3x minus 12 plus x plus 2. I'm going to keep simplifying the left-hand side. Combining my like terms, I get 4x and minus 10. Now I'm going to do the right-hand side. So again, this one's a little different than what we countered. So that minus needs to distribute. So we bring down the 6x minus 2x minus 6. And combining like terms, we end up with 4x minus 6. You might see the issue right here, just because there's 4x's on both sides, but let's see what happens. So I'm going to move the 4x's. I'm going to basically think I'm thinking about moving this one over here, so I'm just subtract 4x from both sides. So we have minus 10 is equal to minus 6. And if you look at this right here, what is going on? Well, we don't have a variable we can continue to isolate. We've lost our variable. And what happens is, well, because it's a false statement, this is what we're encountering in number 8, that there's no solution here. So there is our answer. Okay. And if we were to go ahead and, it seems like this other one's not labeled right here, but so we can call this, let's just call this 8A. And then we'll call this other one, let me go ahead and just call this one 8B. Well, what we'll do is, again, I would encourage you to maybe pause the video and try it. And what we're probably going to run into, and we will run into, is this other scenario right here. That is to say, we'll get both sides being exactly the same. Whether it has a variable or not does not matter, but at some point you'll run into both sides are the same. So you distribute the 3. You get 3x plus 6, and then I'll distribute the minus 5. So I get minus 5x plus 15. Nothing to do on the right, so I'll just write that now. So minus 2x plus 21. Let's combine our like terms. So the 3x and the minus 5x, and then we'll also combine the 6 and the 15. So that is going to be a minus 2x plus 21 equal to minus 2x plus 21. And if you kept going, you'll notice that whatever you do, as long as you do it to both sides, keeping the properties valid, or that we learned about above and applying those, you'll always have the same thing on both sides. So this is this middle row. that it will always be true for whatever value of x is. So we can say our solutions here are all real numbers. And again, this course doesn't cover complex numbers, but that's kind of the counterpart. So there's real numbers and then there's complex numbers, but again, we don't cover those here. All right, so that handles the basics. What we don't have really in our toolkit yet are how fractions play in with these. So let's go ahead and look at those scenarios down here below. One of the strategies for solving equations with fractions is to multiply each side of the equation by the lowest common denominator. This will clear out all fractions. So, and again, maybe just to phrase the lowest common denominator and another, maybe define it, it is going to be the smallest number that each of the denominators equally divide into. There's a couple ways to find it, one involving like prime factorizations, but that gets a little technical. So look at our denominators here on number 9. The denominators are 3 and 4. If you just count multiples of these, the first common number you run into will be the LCD. So 3, 6, 9, 12, 15, so on. And again, you may have already even observed that it's going to be 12 just because 4, 8, 12. So that is our common multiple, which is going to be the lowest common denominator. That is what we can multiply everything by to go ahead and get rid of them. So in the case of 15, I need to multiply everything here by the LCD. Let me make my pen a little smaller. That'll work. So I need to multiply that by 12. I need to multiply that by 12. And I need to multiply that by 12. There's a couple different approaches you could take to how to simplify these. Let me see the other examples. There's a couple different approaches you can do as long as you just remember to simplify everything. But I think the most natural thing is to just multiply first. So that's going to be 24x divided by 3 plus 12 divided by 3 is equal to 36 divided by 4. And now if you look at all of the numbers, that they will evenly divide. So this is going to be 8x plus 4 is equal to 9. From here, we just go ahead and subtract 4 from both sides. So you have 8x is equal to 5. And our answer here, when you divide both sides by the 8, is that x is equal to 5/8. And it's fine just being left as a fraction. All right. Let's do maybe, what do we have here? 1 or 2 more examples. Yeah, we'll do both of these examples in the video. You may want to pause it just to give it a try. In the case of number 10, the LCD is going to be 10 because 2, 4, 6, 8, 10. There's the 10. 5, 10. There's the 10. And obviously 10 is a multiple of itself. So I'll multiply this by 10. I'll multiply this by 10. And I'll multiply this by 10. Maybe I should have said this before, but I'll say it now. Essentially what I'm doing is I'm just multiplying both sides of the equation by 10. So that scales them up, and then I could always divide them by 10 if I needed to. But whatever you do to one side is fine as long as you do to both. So let's see. We end up with a 20x divided by 5 plus 30 divided by 10 equal to 10 divided by 2. All right. Now this is going to be 4x plus 3 is equal to 5. Let's subtract 3 from both sides. You end up with 4x is equal to 2. And then you have divide both sides by 4, and you have x is equal to 2/4. First time we're encountering a fraction that could be further simplified in the lessons here. But both of these numbers could be divided by 2, so it's more commonly written that our solution is going to be 1/2. Number 11 is a little bit different, but you just have to kind of take a look at what we are encountering. It might be easier to do 12. We'll just do it in order. So remember that this is over 1. So I can rewrite this problem as x plus 6 and technically times 1. I'll just write that here, divided by 3. That is equal to 2 times x minus 10, all divided by 5. So what we'll go ahead and do now, let me zoom in here a little bit, is you could distribute the 1 if you want. So this would be x plus 6 and divided by 3. And then you have the 2x minus 20 divided by 5. And just to be consistent with what we did above, there's different ways you could approach this. Like you really could go ahead and just multiply both of these, but you have to remember that it needs to be a quantity. You could just undo the fraction combined. So you could write this as x divided by 3 plus 6 divided by 3 equal to 2x divided by 5 minus 20 divided by 5. Simplifying a little bit further, you end up with x divided by 3 plus 2 is equal to 2x divided by 5 minus 4. So it's one of those things that we're kind of now where we were before. So that might be worthwhile just to simplify everything out first. All right, now what I'll do, the denominators here, and again, it's understood that this is technically 4 over 1, 2 over 1. So the LCD between 3 and 5 is 15. So I'm going to multiply everything by 15. And I'm going to go over to this next, I'm going to go over here. So we end up with 15x divided by 3 plus 2 times 15, which I'll simplify to 30, is equal to 30x divided by 5 minus 60. So 15 divided by 3 is going to be 5x plus 30 is equal to 30 divided by 5 is 6x minus 60. I'm going to subtract 5x from both sides. At the same time, I'm going to go ahead and add 60 to both sides. And we end up with 90 is equal to x. So there's our solution. All right, in the case of 12, it's very similar to what we just encountered. I would encourage you to pause it and give it a try. But I'm going to break apart the fractions. So this will be x over 3 plus 2 over 3 is equal to x over 4 minus 1 over 4. And the LCD, the least common denominator between 3 and 4, is going to be 12. So I'll multiply everything by 12. So this gives me 12x divided by 3 plus 24 divided by 3 equal to 12x divided by 4 minus 12 divided by 4. Simplifying each fraction, this is going to be 4x plus 8 is equal to 3x minus 3. All right, and to finish things off here, I'm going to subtract 3x from both sides of the equation. And I will then at the same time subtract 8. So we end up with x is equal to minus 11. There's our solution. These could be a little bit tricky just because of the amount of steps required to successfully solve them. So practice them and make sure that you're careful each step along the way. Now, the last thing that we're going to look at right here are one strategy for solving equations with decimals is to multiply by a multiple, that should be multiple of 10, so that it will produce all whole number terms. This will clear out the decimals. So you could go ahead and just work with the decimals as well, but I'll go ahead and illustrate the example above mentioned, the directions mentioned above here And then I'll just do one directly with 14. So in the case of 13, I'm going to multiply. I have, if I look, that's in the 10th place, that's in the 10th place, that's in the 10th place. So everything, the smallest I have is the 10th place. So I'll just multiply everything by 10. So that would actually move you could verify this, but it'll move the decimal point 1 point to the right, multiplying everything by 10 to get 4 plus 2x is equal to 8. And then we'll subtract 4 from both sides. 2x would be equal to 4, and then dividing by 2, we'd end up with x is equal to 2. So that's if you choose to scale everything. In the case of 14, again, just to illustrate, you could do this directly. I'm going to go ahead and subtract 0.12 from both sides. So that would give me 0.11x is equal to 0.22. And if I could divide both sides by 0.11, 0.11, and again, this is where maybe a computational device would help, but x would be equal to 2. And again, you could just look, like ignoring all of that, 22 divided by 11 is 2. All right, number 15 is very similar, so I will leave that one as an exercise. You could, of course, check that answer at the next page, but that will cover the basics of solving linear equations. And maybe one last thing to finalize the terminology. A linear equation is just equation involving only constants and a single variable, so most commonly x right here. So we're going to look at how to graph these when we introduce a second variable, but again, if you want to graph it now, it would basically just be a number line, and you would just have the single point wherever it is too. So linear equations just consist of constants and a single variable here. We'll figure out what to do with another variable later. But again, make sure you practice this. These are the basics for all of the things that we're doing the rest of the chapter. And again, just remember my caution. Don't let a false sense of, hey, I've seen this, lure you into not putting in the time you need to do good and even great work, I should say. So good luck and have fun.